Esteemed colleagues, thank you for taking your seats. This is a reminder once again. Please silence all mobile devices. Thank you.
To make the leap from what's possible with AI today, to push beyond limitations like privacy, computational power, and the confines of the cloud, we've built something revolutionary, something dynamic, fluid, liquid. The Liquid engine is a true innovation that will allow every company to own their own intelligence. It allows every step of model design and training to be tailored to the specific needs of your company, whatever they are, today or in the future. Models that are more memory efficient, more explainable, and higher quality, giving you the power to scale up or down at an affordable cost, making what has, up to now, been impossible, possible, like enabling autonomous drones to find brush fires before they become wildfires, analyzing a patient's entire medical history against their unique genome, or detecting manufacturing anomalies using multiple modes of sensor data. Whether you need a model that fits entirely in the palm of your hand, or models that will solve the world's biggest problems, the future of AI should not be limited. It should be liquid.
Please welcome Ramin Hasani, CEO of Liquid AI.
Good morning, everyone. Welcome to the first Liquid AI event, where we're going to talk about a lot of cool things we've been doing the last year and a half at the company. So, as you all know, we are in transformational times. We are in a new era of statistics. What we are experiencing, it's amazing because we started the scaling foundation models. We started building models larger and larger. We put, a lot of energy into, break the barriers and get into the regimes where general properties, general knowledge can actually emerge from a scaling neural networks. And that allowed us to get into a new era. In this new era, AI is changing everything. AI is helping us to discover new math, discover new physics, discover new drugs. AI is allowing us to solve science. A lot of the impacts that AI has, it's going to help us become the next, contribute to the next generation of evolution, even. But AI also have some limitations. So what we have to think is that scale doesn't come for free. You're spending a lot of energy to actually get there. At the same time, when you scale systems, you're getting into, troubles like carbon and, like the sustainability aspects of the whole technology. It is good. The goal is amazing. But what we have to deal with is also some of these challenges. It's not only this, but everything is increasing. So, another aspect which is very important, is that we are scaling black boxes. What we're trying to do, we're basically like building systems with elegant, simple mathematics. We take them to the next stage. But then it becomes harder and harder as the scale of these systems become larger to understand what happens. So we're losing control. So it's not that easy to be ignorant about these issues. These are from the scientific and technological kind of perspective on AI. But when we talk also to enterprises, let's see like some of those challenges. You're hearing, like when we're interacting with enterprises, we see people say, the quotes from people that we talk to. What if I don't have internet connection if I want to use these powerful AI models? What if I want to personalize these models? What if I want to have AI systems, but I don't want to spend that much energy, that much kind of capital into designing these systems? Why do we have to spend millions of dollars to get there? Now, and a lot of other quotes that we're hearing about the implications of this thing. These are the realities we're facing when talking to people. And these are the underlying consequences of scale. Or this one, GPUs. What if I want to run my systems on CPUs? And a very important matter, what if my data can't leave my premise due to file size, regulatory requirements, or privacy concerns? We built Liquid AI to actually enable us to get access to generative AI in a smarter way. We want to enjoy the benefits. We built the company with the mission to build very capable and very efficient AI systems that are general purpose at every scale. So if you look at this vision that we have, we want to get smarter about scaling properties of these models. This trend is there, is not stopping. But what we are trying to do is that can we do more with less? That means if we are in a smaller parameter regime, can we unlock better capabilities with AI? If you think about it from first principles. And we did just that. We built something that we call Liquid Foundation Models. We released 3 weeks ago the first batch of language LFMs. These models actually elevated the scaling laws that we've seen before into regimes that higher quality models are now possible at smaller scale. At every scale, we released a 1.3 billion parameter model, we released a 3 billion parameter language model, and a 40 billion mixture of expert system that allows you to have this technology at every scale, enabling general purpose computing. Be it a chat applications, be it a reasoning or a mathematical kind of question, or if you want to put it in production for performing a task for you. Liquid foundation models are neural networks. They're large neural networks that their computational units are rooted in control theory and in signal processing. And this is a completely new way to look at AI systems. With LFMs, we want to change the base of AI. So another property of LFMs is that we are not just looking at increasing the quality of models, but we want to also be better and more efficient at the same time. So usually when you use a foundation model, you are giving it a couple of contexts, and then the model generates for you more kind of tokens or outputs, and then that tokens are increasing. As those tokens, as you use the model, the amount of kind of information that you actually extract from the model, increases. Now, that will lead to a much higher kind of memory capacity requirement on device. That's why we need higher and higher or better and better hardware. But at Liquid, we enabled something that up to 1 million tokens, you can fit the data that you're using and you're feeding inside the network to map on 16 gigabytes of memory. This was something that was not possible before, while achieving the quality of the models that we get. We released these models, as I mentioned, 3 weeks ago, and the models became trending on, we're not a consumer-facing company, we're serving enterprises, but I mean, it seems like the consumer also love playing with models. Like right next to Gemini Flash and Llama 3.1, we have had a trending model. So I guess today, actually, if you go to Open Router as well, you would be able to see our API is still trending, I think. And that's a testimony for us that yes, so the work is actually paying off. Lower energy, lower cost, the best quality you can unlock from the AI systems. I'm very excited to today tell you that we're releasing more. We're releasing multimodal LFMs. We're releasing an audio LFM and a vision LFM. The audio LFM is just short of a 4 billion parameter model that can fit on a device and can give you seamless audio kind of generation. It can do speech-to-speech, and it can perform, speech-to-text kind of functionality. The vision LFM is going to process text and image and can produce context on top of that kind of image. There are a lot of applications that we can unlock on the edge and on-prem using these new foundation models. We are going to talk about this today, and the team is going to tell you a lot more. But there is also more. So we're going to release a library of LFMs. We have been applying our technology to solving multimodal data of any nature, any sequential nature. This data could be biological DNA sequences. This data could be financial time series. This could be, in any kind of, so for example, in autonomous driving, it could be signals that you're collecting for driving. We're building a full library as products of Liquid. And we're going to talk about this, the team, in a second. But before getting there, I just want to position also the company itself. So you should not think about Liquid as an AI architecture company. We've innovated an AI architecture for sure. But architecture is one element of a foundation model company. So we are a foundation model company. We are putting together a full ecosystem of model development. We have innovated across not just architecture, but on learning algorithms, how to train, how to pre-train, how to post-train, how to evaluate the models. We have thought about this deeply from first principles to get into these qualities and this shift that you see in the scaling laws. So you're going to see a lot today, more details about what I showed. You're going to see a little bit about science and technology behind these models, how we're building them. You're going to see a library of LFMs. We're going to talk about how we can enable this and how we can give people access to the technology so that they can build with this technology through Liquid Dev Kit. And we're going to tell you what kind of infrastructure is ready to be used, deployment. And after that, we're going to have a couple of luminaries on stage to tell you some of our partners, some of our future partners, and some of the key figures of the industry that have experienced with with LFMs and will experience with LFMs on the stage. Okay, so I'm excited. We are going to deep dive in science and technology. Let me ask Jimmy to show you more.
From a technology perspective, much of what Ramin has just shared with you is the result of us building a way to develop high-quality and efficient models that do not require you to have to choose between the two. So I'd like to take a few minutes to tell you more about what we mean by this and how we think about the problem. By quality, we mean the capabilities of the model and the usefulness of the outputs it can produce for various tasks. We consider many aspects of quality, with a few important examples listed here. The first is knowledge capacity, or given a specific model size for a specific regime we want to deploy in, how much relevant knowledge across a variety of domains can be packed into the model weights from the training data. This is important to ensure the model has a strong base of factual knowledge to be used for various queries. Another important aspect of quality that we consider is multi-step reasoning. This ensures that the model is capable of breaking down complex tasks into simpler problems that are easier to solve. We also prioritize long context capabilities, which ensures that the model can effectively use information from throughout its context to solve a task. This was particularly important for us to focus on, because note that just because a model can efficiently process a long context does not mean it can necessarily effectively make use of information throughout that context. When we talk about efficiency, we think about both inference efficiency which determines the cost and resources required to deploy the model, as well as training efficiency, which determines the cost and resources required to develop the model. And it's important to note here that there have been many prior attempts at developing efficient transformer alternatives. In fact, many of the members of our team have performed foundational research in this area. However, prior attempts at scaling these prior methods, both by many others and ourselves, has always led to the observation that you have to sacrifice on at least one of these aspects of quality, if not many. And this is one of the challenges we have been solving at Liquid, and we have developed a way to deliver high-quality and efficient models that do not require you to have to choose between the two. And we have accomplished this by developing a holistic framework for high-quality and efficient model design. Given a particular deployment scenario, we do not only consider the model architecture, which we do and is important, but also how everything interacts together. From the data, the training algorithms, and the post-training procedures, and how all these interact with the architecture and the scenario we're trying to deploy in. And this view has allowed us to innovate in each of these areas. And a key driver of this innovation has been our careful design of fine-grained internal evaluations, which allow us to pinpoint the strengths and weaknesses of different approaches to architecture, data, and training designs. So I'd like to walk through just a concrete example to give you a better sense of how we think about this, and let's consider one of our internally developed long context capability evaluations, which measures the model's ability to use information from throughout its context in a complex way to solve a task. And I will start by plotting the performance of a strong transformer baseline on this metric throughout a training run. The y-axis represents a quality score, and the x-axis represents the number of tokens seen during training. And we'll note that at the end of training, the transformer achieves what we would consider to be a high quality score. And we found that in practice, when combined with high scores on our other evaluations, this is predictive of strong performance on real-world applications that we care about. Now, on the other side, we'll also plot the memory footprint that the transformer requires to solve this task. And we'll note that, of course, the transformer requires what we consider to be a large memory footprint, which makes it expensive to deploy. But now we can also plot the performance of two previously proposed efficient transformer alternatives. One, a modern input-dependent state space model variant, and the other, a modern gated linear attention variant. And we see that while on your right, the memory footprint of these efficient alternatives is very favorable compared to the transformer baseline, we also notice a large quality gap between the performance of the transformer and these efficient alternatives. And we found in practice this gap was significant and predictive of very important failure modes when trying to apply these previously proposed efficient alternatives on downstream tasks. And of course, this is just one of our many evaluations that has allowed us to identify other important failure modes not previously recognized. And this created clear paths for innovation. Of course, the first release of our LFM models are a very early result of these innovations. Focusing in on the performance of the LFM versus the transformer, we see that the LFM actually improves upon the quality score while maintaining the very favorable memory footprint, allowing us to deliver on the cost savings. So these are the types of challenges we are solving at Liquid. And this is just a very brief preview to give you a sense of how we are delivering on the promise of high quality and efficient models that do not require you to have to choose between the two. Now, another important core component of our framework that I have not spoke much about are our post-training procedures. So I'll now invite to the stage our senior scientist and head of post-training, Maxime Labonne, to tell you more about this. Thank you.
Okay, thanks, Jimmy. Hi, everyone. So here I'm going to talk a bit about the post-training work that we do at Liquid AI. So during pre-training, models are trained on a lot of data to learn general capabilities. But we need to tune them to turn them into useful assistants that can answer questions and that can follow instructions. This is the goal of post-training. By creating high-quality examples, we challenge our models to learn how to answer complex questions with multiple steps and with advanced knowledge. But this is an iterative process, and to monitor our progress, we need the best evaluations. So in addition to the internal evals that Jimmy talked about, we have an entire stack of evaluation at every stage of the training process. These evaluations can guide the pre-training and post-training process to know when we achieve the right level of performance. Public benchmarks allow us to confirm our internal scores and also compare our models with our competitors. But this is not enough to make great models. To make great models, we also need to evaluate their chat capabilities, how they interact with users. So to do this, I'm really excited to talk about the liquid arena that we created. So in this arena, we have two anonymous models, and they provide an answer to the same instruction. Then we ask a human to choose the best answer. We can repeat this process with a lot of instructions and a lot of answers to understand where our models are good and when they underperform. But to scale it to millions of instructions and answers, we created an automated version of this arena, where we replaced humans with LLMs. This gives us a fine-grained understanding of the capabilities of our models. All these evaluations provide feedback on areas of improvement for us. So for example, if we see that our models are not great at summarizing text in German, for example, we can create better data, retrain our model, and fix this issue. So to do this, we have a custom preference algorithm that can process and learn from human preferences very efficiently. In addition, Liquid's training recipe also includes distillation and model merging. So with distillation, we have a big teacher model and a small student model. The student directly learns from the outputs of the teacher. This effectively compresses the high performance of the big model into a much smaller one, which is both cheaper and faster to run. Then there's model merging. This one I'm the most excited about. So during model merging, the idea is that we merge the parameters of different versions of the same model. And this creates a single, unified, high-quality model. This combines high performance across different tasks, and this also allows us to upcycle our experiments into better models. So all of these techniques in the post-training world, they allow us to create and deliver best-in-class models. We also have a strong focus on evaluations to target fine-grained capabilities in our models. Finally, for end users, this delivers better customizability to adapt LFMs to particular tasks and domains of interest. A good example of this is the Japanese model we co-created with CTC. Here, we fine-tune LFM 3B on Japanese data, and we created the best Japanese edge model on the market. This is confirmed by both public benchmarks and also human preferences we got from the Liquid arena. Okay, so now we've covered all of the model cycle that we do at Liquid AI. Now, let me introduce Alexander, our CSO and co-founder, to talk about the principles behind LFMs that go beyond language. Thank you.
Thank you, Maxime. Hi, everyone. This is so exciting because what you've all seen so far today is how Liquid is building best-in-class language LFMs that are state-of-the-art in both efficiency as well as accuracy. But today, we all know that large language models, like LLMs, are extremely overhyped. And Liquid AI is not a language modeling company. Liquid AI is a foundation model company. We build LFMs for all types of sequences. And language, well, language is just one sequence. In reality, sequences are everywhere in the world. And in order for AI to be everywhere in the world, we need LFMs to be highly capable on all sequences. And that's exactly what we're doing at Liquid AI. Today, we unveil a suite of LFMs that are going to revolutionize across domains and industries. Let me tell you a bit more about how Liquid foundation models are revolutionizing biological and therapeutic design. We've already seen so far today how LFMs have learned the language of our natural language. But actually, LFMs can learn the language of biology as well. Here you can see BioLFM. BioLFM learns the language of proteins. It learns how to generate brand new proteins from looking at the entire existence of all of these proteins that exist in the natural world. BioLFM is highly capable and highly efficient to generate brand new proteins that have never been created before, but we can now create them in the lab. BioLFM is so efficient and scalable that we can do this not just for one protein, not just for 5 proteins, but at large scale across biology and accelerate biological discovery and design. It doesn't stop with just efficiency. BioLFM scales to capability and accuracy as well. BioLFM is state-of-the-art, best-in-class, accurate protein foundation model at this scale, and we are still scaling and improving this model to bigger scale and moving these digital generations into the actual lab. Now, Liquid AI and LFMs not only enable everything from understanding the biological world, but we extend to also understanding our physical world as well. This is critical because our physical world is so complex, it's so dynamic and ever-changing, that in order to deploy autonomous systems into the physical world, we need to be able to understand and simulate our physical world. This is so challenging because of all of these complexities that the physical world entails. We built Drive LFM to understand our physical world so that we can test and simulate new environments of our real world for these autonomous systems to be stress tested and verified before they go out into reality. Drive LFM learns from our world how the world works to understand the world using a sequence of past video. Here we look at driving as a particular impactful example to understand the world, and then learn how to predict the future. Learn how to generate brand new futures for every single scene, every single environmental condition, time of day, weather condition, and so on. Drive LFM extends to all of these different scenarios. And again, it doesn't stop here. LFMs enable us to understand our physical world, but also understand our own interactions and behaviors. This is so important because when we think about how we interact in our world, it's also so personal and so complex. Every single day, each one of you is transacting, is interacting with other individuals through financial transactions as well as other businesses. And in reality, if we look at this sea of transactions, identifying and isolating a single fraudulent transaction, a single mistake in this massive sea of transactions that occur is a classic needle in the haystack problem. It's a huge undertaking, a huge challenge. But identifying this one fraud is one of the most critical things to ensuring and safeguarding our personal finances and the finances of all enterprises. In fact, if we zoom into these transactions, what we can really see, when we zoom into the sea of transactions, we can actually see that every individual transaction is nothing more than a composition of what makes that transaction a transaction, what you purchased, how much you spent, when you made the purchase, where you were. All of these go into that single transaction. But of course, we all know that transactions don't exist in isolation. This one transaction was actually part of a much larger sequence of transactions that you participated in. Understanding this sequence and predicting what comes next in the sequence is the core problem that we solve with Transaction LFM. Transaction LFM is able to take as input all of your past past transactions, and be able to predict what comes next, which enables us to predict when there was a potentially fraudulent transaction in the mix, so that we can identify and safeguard every individual's and every business's financial. Transaction LFM is able to scale towards large-scale transaction histories, which means that our fraud detection models are very, very accurate because it learns from all of your personal past history of transactions. Using the Liquid technology, because these models are so efficient, we can scale to these regimes, but also it means that they are highly accurate. Now, what we have seen is that LFMs scale to language and far beyond, to all of these different sequences. But in reality, when we look at this landscape, we can actually see that LFMs are not only efficient and accurate, they are highly multimodal, which means that we can combine these different sequences together and learn how to talk to sequences. We can leverage language on one side and go into an LFM and also communicate and talk with other sequences. Here, for example, I'm going to show you a demonstration of how we built a time LFM, a time series LFM that you can communicate with directly with natural language. Time LFM is able to ingest both language as well as time series, which is a highly structured and very complex data type. Let me show you an example. Time LFM comes with a very simple interface because it's rooted in natural language, but has a backend of time series. You can directly describe what you want to search for or identify with Time LFM. For example, here, identifying key financial trends, using the language model to query in a multimodal fashion all of the underlying underpinnings of our time series model. It doesn't stop there. We can identify these trends, but we can also use Time LFM to analyze key and very precise time and metadata information. But of course, the most important part is because this is not just a wrapper on top of a language model, this is a multimodal time series combined with language model. It means we can actually understand the dynamics, the behaviors of what's happening in the time series. Things that are not only located in the metadata description of the time series that you could get from a Google search, but actually going deep into the time series and understanding the behaviors of the time series, and then interfacing with this through natural language. For example, here, looking at a funny use case of trying to uncover cryptocurrencies that have had market manipulation. All of these are examples of how time LFM are revolutionizing the ability to not just have language models that you can communicate in and out with language, but can communicate through all of these different sequences that we've been talking about today. And this is just an example of how we've been scaling LFMs to achieve highly efficient, highly capable, and accurate modeling that is fundamentally multimodal. Now, how did we do all of this? We built LFMs using what we call the Liquid Dev Kit. The Liquid Dev Kit is a developer package that allows us to build and deploy LFMs for any domain and any scale. Let me tell you a bit about the Liquid Dev Kit. The Dev Kit sits on top of PyTorch, as well as optimized kernels that we have created at Liquid for all of these efficient and accurate operations. It is comprised of a variety of different abstraction levels that allow our internal engineers and scientists to easily build and scale these models across a variety of different levels, starting first from the lowest level of operators, and then moving up to blocks and backbones from there. Our engineers and scientists can leverage DevKit in a very easy-to-use way so that we can achieve all of these incredible LFMs that we're releasing to the world today. In just a single line, instantiating and building these LFMs, and I'll actually walk you through an example right now of how we can have the entire pipeline of building state-of-the-art examples with the DevKit, scaling them to large-scale, highly capable systems, and explaining the outputs, every single output, every single prediction that comes from this model, so that we can certify the model for safety. Let me walk you through an example of how we build with Liquid DevKit. The DevKit, remember I told you, is a composition of layers that make it very easy to scale these systems across all of these levels of complexity. I'll start first with the lowest level, which is the operator level. Operators allow us to take as input a sequence and learn how to transform that sequence. Now, operators typically are extremely complex operations. They take a lot of very low-level optimized code and kernels that's very, very hard to not only write, but write efficiently. The Liquid DevKit takes all of this complexity and removes it. It abstracts all of this complexity away and moves it into easy-to-use liquid operators that can be easily instantiated for your application. We do this for a variety, not just one operator, but a variety of different liquid operators that we package together in the dev kit. This includes both operators which we have created and invented at Liquid, as well as leading open source, highly efficient alternative architectures that exist in the world. We can bring this up a level from operators now to blocks. Blocks allow us to elevate the level of complexity that our models can handle, and they do this by very straightforward gating mechanisms that are abstracted also into the dev kit in the same way. And finally, going up one more level beyond this, we can combine these blocks into backbones. And the unique thing here is that DevKit is able to handle these levels of abstraction and scale them up into the backbone level in ways that goes beyond vanilla transformer in-sequence backbones that we see in the world today. The Liquid DevKit allows us to build backbones that have hybridization or feature sharing or depth sharing, allowing us to move beyond the state of the art today. This is how we build LFMs at Liquid and how we work with our partners to build LFMs. But it doesn't stop there. The Liquid Dev Kit enables us to not just build and instantiate an LFM, but we now need to train it and to scale that model across hardware so that we can achieve the incredible results that you're seeing today. This is done by actually enabling highly scalable and distributed training pipelines with the Liquid Dev Kit. You can see an example here on the left and right side of building that model that you saw in the previous slides. We built an LFM. Here, a very small LFM. I'm going to show an LFM that's only about 150 million parameters. But now let's ask a question of, okay, what if I wanted to build a bigger LFM? What if I wanted to scale this into a multi-billion parameter LFM? Well, this requires me to basically scale the number of blocks, because all the complexity is actually abstracted away into the operators and the blocks. I can just scale the blocks to scale my LFM. So let me increase the number of blocks from 2 to 12. This makes my LFM about 12 billion parameters now. But what happens is actually this LFM, if I put 12 blocks in it, it no longer fits in my GPU. So now, with DevKit, we make it very easy to add one extra line using a devkit.distribute line and take those 12 blocks and split them, to distribute them across our hardware so that we can scale to multiple GPUs, multiple nodes, and have all of those nodes seamlessly communicate with each other to handle this much bigger model. Finally, I'll tell you about how we're able to also take these models that we train with the dev kit and explain every single answer that comes out of their predictions, that comes with their predictions. This is because liquid neural networks were invented to be highly explainable systems. We achieve this explainability through the dev kit, and we package the explainability through the dev kit using what we call model.explain. Model.explain is a very easy-to-use function that comes with every single model that is built with DevKit. So any model that is built with DevKit actually comes with this very special function, the .explain function. .explain takes as input the input of the model, but unlike other neural networks, other AI systems that just take the input and predict an output, .explain explains how this output was generated with respect to the input and with respect to the model. It can do this with respect to going inside of the model, understanding what in the internals of the model made this prediction predict, what in the data did it see to make this prediction get outputted, right? And all across the board, looking at all of these different axes of interaction that our model has with itself and with its data. Let me show you one example of how we've used model.explain with one of our LFMs. So we built a vision language model. This is a model that takes as input both an image as well as a textual description or a textual question about that image. And then the model is supposed to respond in text about this question. So we can ask a question to the model about this image. And you can see the image on the top right here. Describe this image in one sentence. You can see a couple things in this image. The cat is very obvious, but if you look a little bit closer, you'll see that the cat is about to play with something in front of it. There's a small insect, very, very hard to see. Let's see what happens when we feed this image to our vision language model, LFM. Here we can see, we feed it to the LFM instantly responds, and it's able to say and correctly predict that in this image, we can see a cat and an insect on the ground. Okay, this makes sense, but let's look inside the model. Let's say what happens when we use model.explain to explain how we got to this prediction. For each output that the model creates, we can ask model.explain to explain that output, starting first with the very first token, moving on to the image. Once it says in this image, we can see that the model starts to expand its focus a little bit. And then it talks about the cat. It gets to the cat, and you can see that now the focus has shifted. It's now looking at the cat. It's not looking at other places. It is explaining why it's predicting the word cat. It's because it's looking right there. And then you can see it shifts its focus yet again, now looking at the insect, which was so small in the image. And finally, relocalizing itself back into its context, understanding that all of these things happened while on the ground, and shifting its focus yet again from the cat to the insect, now to the ground. This is just one example of how we are using model.explain, but model.explain is deeply embedded in all of our models that we build because they come with the Liquid Dev Kit. Now again, today you have seen how we've built these LFMs that are highly capable, highly accurate, highly efficient, and across the board multimodal for all of these different domains and industries. Today, we release this suite of LFMs to the world, and also we're going to showcase how actually this suite of LFMs, one of the most empowering things I think about Liquid AI is not only that we build these LFMs for the world, but we deploy them to the world at all scales. And one of the most powerful aspects of our LFM library that you can see here is this part about the edge LFMs. Today, and I'll pass to Mathias, who's my co-founder and CTO of Liquid AI, who will tell you more about how we're actually deploying this library of LFMs directly onto the edge in a fully private, fully capable manner.
What if to maximize AI's potential, we need to solve for its limitations? What if a major bank could accurately analyze billions of transactions for fraud without letting a single bit of data leave their firewall on-prem? Or a leading quick-service food company could power automated drive-through windows in rural areas without relying on the internet? What if a chip manufacturer could build a microchip with the power of AI in it? What if a regional telecom company could process and filter their data without sending all of it to the cloud? Whatever your use case is, Liquid AI can develop and deploy solutions that target and overcome the specific limitations of your company with efficient, scalable models that turn your what-ifs into what next. With Liquid AI, it's not if, it's when.
Please welcome CTO of Liquid AI, Mathias Lechner.
So we have just seen in this video why Gen AI on the edge matters, and I'm going to tell you a bit our progress that we have made. Recall the slide from before where we showed that we train LFMs at every scale. Our currently smallest model at around 1.3 billion parameters, a 3B model, and also a 4DB model, our currently most capable and largest variant. And the numbers, the parameter size of each of these models was not chosen randomly, but with a specific target end device to run on in mind. For instance, the 1.3 billion model is able to run on embedded hardware. The 3B is optimized for phone use, and the largest variant to run in the cloud or on-prem on a single GPU. So at Liquid, we don't just train at every scale, but we also deploy at every scale. In particular, we deploy where no one else can. So here, we have a video of a Raspberry Pi. A Raspberry Pi is a $60 cheap, low-power, fully-fledged computer with the compute capability of around a 10-year-old laptop. And we ported our smallest model, the 1.3 billion parameter model, to run on even such small and low-power devices. Particular, asking about the isotopes of hydrogen. I was the wrong video before, but yeah. Here we see that the model is responsive and can make use of even like the low power and like the small and cheap hardware of the Raspberry. So this is the smallest model, which is nice. But let's take a step and look at the other side of the spectrum of our currently largest model, the 40B. In particular, one thing that Jimmy mentioned is that we also look into making sure that our models can make of long context. So they are memory efficient, but we also make sure that they are making use of all of the context that they're provided. And in particular, we can then feed additional data and information that is not in the training data into our model. In particular here, we can add the web search functionality and augment the model with post-training, like data that's not in a training, with data that's not in a training set. Particular lookup for my co-founder, Alexander Amini. Look up his profile using the web search, which is quite nice. So these are all, so far, text models, like text in, text out. But Alexander mentioned to you that our models are natively multimodal, meaning that we can have conversations with our model.
Hello, what's your name?
Hello, my name is Liquid Edge. I'm a real-time voice assistant here to help you with questions and tasks.
Can you tell me one thing to do in Boston except the Freedom Trail?
Absolutely. One great thing to do in Boston, aside from the Freedom Trail, is to visit the Boston Common. It's a beautiful park in the heart of the city where you can relax, have a picnic, or even play a game of catch. It's a great place to enjoy the outdoors and take in the city's vibrant atmosphere.
Can you give me one short tip for networking at a tech launch event?
Absolutely. One tip for networking at a tech launch event is to be genuine and approachable. Start by smiling and making eye contact when you meet someone. Ask open-ended questions to show your interest in their work and to encourage a conversation. Remember to listen more than you talk, and be prepared to share your own experiences and insights. Don't be afraid to follow up with a LinkedIn connection or an email after the event to maintain the connection.
Thank you.
You're welcome. How can I assist you further?
So this was our three So this was our 3 billion parameter speech model. And due to the native multimodal support, provides low latency with, after the user provided some instructions for the model. Today's large language models are all running in the cloud, connected through an API. But what if we don't have a reliable internet connection and want to make use of GenAI? Or what if we have privacy and security concerns that we don't want to share our data with a potential API provider? We at Liquid deploy where the device is and not where the connections are. Instead of telling you about it, let me show it to you. So here we have our app where we can chat with our offline model. Let's also turn off the Wi-Fi and ask it something. Halloween is coming up soon, so let's test the creative writing abilities of our model. Give me 3 AI. Sorry. AI-themed Halloween costumes. So this is our liquid neural network necromancer, as deep learning droid, and generative adversarial knight. That's nice. Quite creative, yeah? Let me write a scary story about, what was the first one? Neural network necromancer. The title, the Necromancer's Awakening. And yeah, I'm not going to read it out, but I think you get the point. So this is our 3B language model running fully offline on an iPhone. That's one of the things we have achieved at Liquid. So far, we have seen chat models, so basically open-ended conversations with the model through speech, through text, and so on. But what if we have a custom application where we want actually the model to be tailored to a specific use case? And we created a hypothetical use case where we want to use our 3B speech model, and we tailored it using a fine-tuning approach to a tech support customer agent. The customer, this agent takes unstructured speech input, irrespectively of format, and translates it into a structured format that is machine processable and readable by a machine. The video also, let me just roll it.
Customers reporting that their TV is not turning on, and they're suspecting this is due to a recent software update, and customers tried to turn it on and off and unplugging and replugging. Customer's full name is Robert Wilmot. And could you summarize the issue? And give me a short classification.
So we have seen my colleague Mark basically using this demo, taking speech input, translating it into structured format, using the classification abilities of the language model as well as the summarization abilities. But as I mentioned before, we at Liquid bring the intelligence, the Gen AI, to where the devices are. So let's run it again, but making sure and showcasing that it runs fully offline.
Customer's first name is Lily. Last name Banazak. Correct that to Banazak. Customer is reporting potential malware infections, so whenever they turn on the computer, essentially there's only a red screen, and basically the computer is unusable. And could you provide with a classification, please? And can you summarize this issue?
Awesome. So we have seen now like a potential commercial application of our speech LFM fine-tuned on a specific task running offline. We at Liquid unlock the power of generative AI on devices that were once out of reach in a fully private and secure manner. We have seen that we train LFMs and our foundation models at every scale. We also deploy them at every scale. In particular, we have seen it as small as a Raspberry Pi. We have seen that our models are multimodal, taking speech and vision input. We have also seen that our models can be fine-tuned and tailored to customer applications very easily. So let me hand it back to Ramin. Thank you.
All right. So what do you think? We are a foundation model company. We're building the most capable, the most efficient AI systems the way you haven't seen before at every scale. So, as you saw, we can develop and we can deploy these models today. We do this for on-prem kind of solutions that you want to have or on device, as you've seen throughout the talks. LFMs are private. The solutions that are enabled by LFMs can be explained. The dynamic can be explained. They're high quality. They're reliable. You can use them for many, many different applications. Now, if you really want to engage with us, we would love to work with all of you. We want to give you a couple of opportunities. If you want to develop AI on the edge, if you want to deploy that on-prem, you can talk to us. You can come to our team, and we can have like conversations about those use cases that you might have imagined building with Gen AI, and you want to do that in an efficient way. You want to do that with the highest quality and more reliable kind of version of your models. This is where you can contact us. The other thing is that we also provide a co-development kind of opportunity, because we're still early on in our journey, to building these LFMs for many, many different applications. There are some applications maybe we don't have even a visibility into, but you've seen, for example, we wanted to enlighten you with a kind of a taste of what kind of possibilities, what kind of things we are thinking about, we have thought about for co-development and deployment of AI systems. So, you heard from our team. In the next chapter, we are going to see some of these LFMs used by some of our partners. We're going to have conversations with our partners on stage. And some of the luminaries are joining us, including the governor of Massachusetts. And we are going to talk about the impact that we can bring with LFMs, revolutionizing how AI has been deployed in the society. So don't go anywhere. We are going to do a 15 minutes intermission, and we are going to be back with the panel discussion. Thank you.
Ladies and gentlemen, please enjoy this short intermission. We will resume programming at promptly 11:30. Thank you. Ladies and gentlemen, it's time to take your seats. Please silence all mobile devices. Once again, please silence all mobile devices and take your seats. The program will begin momentarily. Ladies and gentlemen, please take your seats. The program will begin momentarily. Please help me welcome the Governor of the Commonwealth of Massachusetts, Maura Healey, and Liquid AI CEO, Ramin Hasani.
Okay. Amazing, amazing. So, Governor, let's just get into it.
Yeah.
Why do we have to put our headquarters here in Massachusetts and not in California?
Oh my God, where else would you want to be?
You know?
Right? I mean, look, you know this, right? I mean, you just saw the demo, and it reminds me, you know, of the shots first fired in Concord in Lexington, Massachusetts, that gave birth to this great country, the United States of America. Massachusetts, we have been about revolution and innovation from the very beginning, and that's why it makes sense. It also makes sense because, you know, here we are at MIT, right? And you came here, Daniela, others came here to study, to learn, and have now found the place to birth a business, and not just a business, but like that 250 years ago, skirmish on a battlefield, what you guys are doing is revolutionary. It's going to change the world. So that's Massachusetts DNA. And, you know, I'll also say this. Last night, I had a chance to see the banner raised at TD Garden for our Boston Celtics. Banner 18. The most storied franchise in all of sports history. And, you know, I appreciate Steve and Nick Pagliuca, and for so many things, and especially, of course, last night, their stewardship of the Boston Celtics. I think about Boston. Do you know who they whooped last night? The New York Knicks, okay? So while there are some cities, New York, San Francisco, maybe bigger, you know, OpenAI, there's stuff happening there. Boston, I will tell you, kicked New York's ass because we are more nimble, more innovative, more scrappy, just like Liquid AI, who's found a way to like leapfrog everything by doing things twice as fast with half the energy, which leads me to my final point. You know, we've got big goals around climate here, you know, sustainability. We lead the nation when it comes to climate policy. And I love that you found a way to do this and do it with half of the energy. It's incredible. So that's why it makes so much sense that Liquid AI is here in Massachusetts. Woo.
Thank you, Governor.
Thank you.
Thank you. So from the state point of view, how are we making sure that we are positioning well in this new AI revolution that we're experiencing?
You know, I think it's about leadership. And as Secretary Yvonne Howe, our great Secretary of Economic Development, she's doing a great job for all of us. And one of the things she put together was an economic development plan. And, you know, Massachusetts, we are the global hub of life sciences because there was a huge investment made on the part of state government and funding. There was work with our incredible ecosystem of colleges and universities and research institutions, and there was love and support given to that ecosystem. And that's what built it into what it is. It's people like you, right? It's people like you, our founders, our entrepreneurs, that we want to support, including through our economic development plan, which includes a few things, you know, doubling down on life sciences, saying that we're going to be the global leader when it comes to climate technology, and importantly, we want to be the global hub for applied AI, okay? We recognize that others may have, you know, built out AI and have some things going, but the race is on to see who's going to use AI to solve the world's most challenging problems. President John F. Kennedy, a Massachusetts native son, said we don't do things because they're easy, we do things because they're hard. So in the race, the challenge to cure disease, to build resilience, you know, to identify how to bring a higher quality of life for people across this planet, something that Liquid AI is going to enable in absolutely revolutionary ways. We want to support that as a state by leaning into this space.
Fantastic. All the reasons for retaining talent. But what are you going to say about really making sure that our talent are actually inventing the technologies here and staying here in the state?
Well, look, I can brag about Titletown and sports, all right? I don't think there's a better place in America, as seen by last night. The quality of life here. Right now, Massachusetts, just for everyone to know, we have been ranked #1 in education, #1 in innovation, #1 in healthcare. We're the #1 place to have a baby, to raise a family, the #1 place to live if you're a woman. And we are among the safest states in the entire country. Boston is the safest city. This all speaks, it's quality of life. And also, you know this, we believe in knowledge, we believe in science. We're the home to the first public school and public library, right? We invented the computer. You told me we invented AI. Somebody did way back here. Yes, I remember that. So look, you know, there's freedoms that we protect. And that's what I, as governor, am going to continue to focus on with our team, protecting those things that make us great. Now, working on, and I think those things that make us great attract talent. You know, it's why we have students and grad students coming from all over the world. It's why we have companies looking to grow here. We have challenges, high cost of housing. So I've said about fixing that. I just signed into law a $5 billion housing bill that's going to generate more housing all over the state so that we can lower housing costs to keep people here. Yes. Transportation infrastructure, okay? Those of you on the red line, you can knock the red line, but tell you what, for the first time in 8 years, when I started as governor, I put an engineer with transportation experience in charge of that red line, and we have already seen improvements. We are a state that is making those infrastructure improvements in transportation. I put together a team. We've brought back $8 billion from the federal government, the Biden-Harris administration, already in just 22 months. $8 billion going into transportation, infrastructure, housing. All these things, I think, are going to make it easier for people like you to grow and scale here, for our scientists and researchers and graduate students and teaching fellows to actually stay here, and for businesses to look to expand here. And you are just going to be so integral to that because, as I say, you're able to do something twice as fast with half the energy, and we're going to sync up and make sure that we are supporting you because I know it's going to be great things for economic development for our state.
Amazing. Thank you. Let's talk about AI regulations. What is your approach? What is the state's approach compared to the Californians and other nations?
I embrace AI. I embrace AI. Some of you may or may not know this. I was the Attorney General here. I actually worked with Kamala Harris when she was Attorney General in California. And I'm quite familiar with laws and regulations, and all of that serves a purpose. But I think what we've done in Massachusetts in AI is different. One of the things that we did, and I thank Secretary Howe, Secretary Jason Snyder, who is our Secretary of Technology, we set up an AI task force. And some of you, I'm looking out, are on that task force. You know what that task force is about. It's not about regulation. It's about innovation. It's about how do we work together to seize this moment to make sure that Massachusetts is the global hub for applied AI. I think we can lead in innovation, we can scale this, we can figure out what we need to do, while also, of course, being mindful of doing so in a way that is thoughtful and doesn't do an injustice to people or to populations. We can do both at the same time.
Absolutely. So let me conclude by asking you the last question. So I want to ask you about like AI is expensive. AI needs investment. How are we in the state making sure that we get the right amount of investment in place for AI ventures and AI entrepreneurs to actually become innovative and contribute more and become more and more competitive?
Well, I'll start with $100 million. That's what we'll give you, $100 million for applied AI. And I think what we can do is we can leverage that with existing venture money that's here. I mean, we are fortunate in Massachusetts because I think, per GDP, we have probably the lead when it comes to venture funding, and so much of it is going in this space. So I think if we work together as a team, as Yvonne says, and she'll give you all these bracelets, Team Massachusetts, and we're proud that Liquid AI is on Team Massachusetts. It is about teamwork, working together, how we leverage state dollars, private investment, and the great work of our colleges and universities and research institutions to really blow this open and get this done. I'm so excited about what's possible. As a state that invented the rocket ship, and we did, I just can't wait to see this all just take off.
Amazing. Give it up for the governor of Massachusetts, Maura Healey.
Thank you.
Thank you.
Awesome. All right. Awesome. It's going to be great. Okay. Bye, guys.
Please help me in welcoming Ranjit Bawa, CTO, Deloitte.
Woo!
Hey, Ramin. Good to see you. Thank you. That's a tough act to follow.
All right, let's get into it. So we thought that let's talk a little bit about future of work, okay? As someone that has visibility into a lot of things that goes on in the world of AI and these technological evolution. What I was thinking is that how are we thinking about AI replacing jobs? Is that something that we have studies on? What are the impacts of this technology right now in the future of work?
Yeah, for sure. First off, it's good to see you, Ramin. It's been a while. You know, we first met in Central Park. I biked over. We were looking a little more disheveled than today, so I'm glad we both cleaned up. But AI, certainly, it's top of mind. There's no CXO or board conversation we have today that AI is not part of the agenda. There are many studies that have happened based on the persona of work, the different levels of optimization, et cetera. We certainly think for most of our clients, and we serve 95% of the Fortune 500, there's going to be a significant impact, anywhere from 20 to 40%, depending on the persona. But that also means it's going to open up all kinds of new opportunities that folks are not focused on today. Even for our business, while we may find that we will get to a point where we'll have a 10x auditor or a 10x analyst or a 10x tax professional, there's so many more things that need to get done that will unlock through AI. So I'm more optimistic than most in terms of the real opportunity ahead of AI, in terms of doing what we do today, faster, better, cheaper, but then opening up all kinds of other avenues.
Amazing. And then given the speed of AI advancement, what can businesses do to future-proof their operations? Because now we are having concerns, like people are losing jobs, or how are we thinking about these processes, and how are we making sure that the operations are getting done right from the enterprise perspective and from the people's perspective?
Yeah, I mean, I don't know if there's any such thing as future-proofing the business. I think we're in this stage where we're going to constantly change and be ready to embrace that change. I think what you guys do at Liquid is a case in point for many of us, right? Just in terms of constantly challenging orthodoxies, pushing the envelope on rewriting the rules and things of that nature. I think organizations that need to be resilient need to be similarly configured, to be constantly challenging orthodoxies, urban legends, to build structural agility so they can pivot more quickly as new shifts come, whether they are technological or regulatory or geopolitical. And being able to do that is the best way to be able to future-proof. And then constantly rethinking their products and services and business models. And we do a lot of that, and we don't take that responsibility lightly, because that's a great opportunity for our clients to also rethink their business constantly. And where we are partnering together on a number of those as well.
Yeah, let's talk about that a little bit. So how are we, tell us a little bit about the partnership that we're trying to build.
Yeah, so, like the governor said very eloquently, we are in the business also of applied AI, applied engineering, applied tech, applied AI. So our partnership is quite perfect in that regard, because we very much focus on domains, industries, functional domains, etc. And so if you have to talk about anti-money laundering in financial services, or investment advice for investment manager, which is your background as well, or disease pathology, we can bring some of that deep insight working with our clients and with Liquid AI to bring that to life, both in terms of POCs, but then scaling rapidly across the enterprise. And as you know, the enterprises in general are slower to move, and navigating them and being able to have them embrace this and be able to leverage and show results quickly is critical. And I think that's where we naturally come together quite effectively.
So that's one of the values that we unlock, is one of the products that actually we put out is private machine learning. So can you give us some examples of how we can use that?
Yeah, most certainly, right? We serve in a large number of regulated industries. In fact, we are also partly regulated because of our audit and independence business. And a lot of our clients, just like us, are not going to, at any point, be willing to put our data out there. It's sensitive, it's our IP, it's critical to our mission and vision. So as a result, in a future world, we absolutely envision a hybrid world where there's going to be private LLMs and private LFMs, as well as in the public domain. And depending on the workload, the sensitivity of the data, the regulation, the geopolitical environment it's operating in, we're going to be able to have to navigate those seamlessly. And hence, the opportunity to create a single pane of glass, be able to create operational and trustworthy view into that world, and navigate that effectively is quite key.
Amazing. So tell us also a little bit about your view on the challenges of AI. Right now, what kind of challenges are we seeing that the generative AI is using? Obviously, everybody wants to use this technology. Everybody is hungry to getting access to this general AI. From a technology's perspective, I can tell you that what we see is people have to get technical. This technology is deeply technical, so you really have to understand it. but what are the challenges do we see from the adoption point of view, and what can we do to facilitate that?
Yeah, that's a great question. So, over the last couple of years at least, there's a general sense of realism around what AI can do and how to adopt and apply it. So if I was to maybe look at the 3 things that bubble to the top, the first one is really a focus on real ROI. As in, are they getting the value for the investment, and what is the line of sight to that value? And the fact that you have fundamentally rethought the model to get to a more efficient model and a step function change in the price performance curve makes a huge difference just in that conversation. The second big challenge that our clients continue to face, and us as well, is still trustworthiness. Trustworthiness, observability, the white box construct that we've talked about as well is quite critical, because for regulated and unregulated businesses, being able to understand and explain AI and the explainability is quite key. And part of that is also the financial governance around it and observability. And the third, which I think is really critical with all such change, is the people dimension of this. How do we drive and embrace change in a way that people are not threatened by AI, but can embrace it and do other things and be able to uplift their own focus, etc. So we're focused on all those 3 things, and just like other shifts that have come in the past, we expect this to also be embraced. It's just coming at us much faster. So some of the existing paradigms have to be challenged and rethought, and we're in the midst of that, all the time.
Amazing. So, do you think in the future we're going to have AI CEOs and CTOs?
Never say never, right? I think I'm quite easily replaceable, maybe already. But I think there certainly are, ways. Certainly already, it's not, already people have, CTO co-pilots and CEO co-pilots and the likes, which certainly make them smarter in every conversation. We use it all the time. We have a big team here. A number of our AI leaders are in the room. A number of them are from Boston and from Massachusetts. In fact, our AI leader, Jim, is based here. So even the governor's comments about making this an AI hub is quite key. And we are very focused on creating the right personas and agents for all of those personas, right? A tax analyst, a CEO, a CTO. So, it won't be long, and maybe we should do that together.
Yeah. Replacing ourselves.
That's right.
Okay, so, and then last question for you. Mm-hmm. As a business executive, what are your applications of Gen AI? Are you using AI every day?
Yeah, we're using AI every day. We have been for the last couple of years now. Now, obviously, that, more than anything else, to set the tone across the firm. So our leadership team, our CEO down, is a big embracer of AI. So, that also helps us better understand what's working and what's not working. We're using it in collaboration platforms. We're using it to prepare for meetings, for research reports, for insights in various conversations, etc. as well. But we're also pushing it down through the rank and file. Obviously, our developers are doing a number of autonomous coding platforms today, as well as our implementation work, our tax and audit professionals as well. So very much. And like you alluded to, you have to set the tone at the top. Otherwise, the change just becomes harder and, takes longer.
Absolutely. Thank you so much, Ranjit.
Great.
Give it up for Ranjit, Bawa.
Great to see you.
Thank you. Thank you.
Please help me welcome Raymond Liao, Managing Director, Samsung Next.
Hello, hey. Long time no see, Raymond.
Oh, yes.
Okay, so let's get into it.
Very good.
From your point of view, why do we need generative AI on device? From a technical and from a business perspective.
Yeah. So this morning I was still in Orlando attending Gartner IT Symposium, right? The one buzzword that across the whole symposium is AI agents, okay? This is one of the largest gathering of CIOs, okay? So now from business angle, we say, okay, what's going to happen with generative AI, which is 2 years old? So far, most of the activities has been on the infrastructure layer. But the key question is, what's going to be the application? The sense is that it's going to be AI agent-empowered services, end-to-end services, because now you have AI, you can automate a lot of things. You can deliver end-to-end services to user. and where would the request be generated and the service be consumed by most of the users? It's likely going to be on your smartphone or future, even smaller devices you wear, regardless whether it is consumer or business. So that's why, from our perspective, generative AI is actually a big opportunity for a device vendor like Samsung. Okay? My personal opinion is probably bigger than the mobile cloud era. And the technology-wise, it makes a lot of sense. Because when you think about put the user first, what's the user experience? Can they tolerate the latency? Can they tolerate sending all their private data to the cloud? Or from the service provider perspective, can they tolerate burning all those dollars on inference, serving all those hundreds of millions of users? So there are many reasons, technically speaking, we need to have more compute and more data stay at where they are. You move the compute to where the data are. Those are the personalized data, personalized experience that belong to the user. Stay at where they are.
What makes it challenging, like to bring AI on device?
What we see already, right, is that many, I would say, flagship apps, they use many models. Okay? It's not just one model power one application. They use many models. Now you say you have, in my phone, you have maybe tens of these kind of applications. Then think about how many models I have to maintain and manage their lifetime, life cycle in my phone. So it's very challenging. And I have a power budget. This thing should not drain too much power. I have to make sure that I patch right away. If there's a bug in there, there's a vulnerability happen, I need to patch them. Right? And you guys already showed it, right? It's actually still hard to shrink a 70 billion parameter model to 1 billion. Right? It's non-trivial. This requires a lot of personalized information. You understand users' context and also their data. Right? It's non-trivial. And it's not saying that I can have just one small model marvelously can serve all the users. Yeah, so for both technical and the business perspective, it's non-trivial.
What do you think the liquid models? I mean, you've studied them pretty well. I think you've read all of our papers already, and I wanted to know what's your perspective on what is fundamental and unique about the liquid foundation models, the way you saw it, so you see fit in this space.
Yeah, maybe I'll dial back a little bit. What does Samsung Next do, right? We are an open innovation and venture investment primarily for Samsung Electronics. Okay? We make one new investment a week. We are very early. How early? We go to major academic conferences. That's where we meet, Ramin and his whole team. Right? We read their papers. What's standing out, honestly, is that when I see from the early days of liquid neural net to when he tells me, oh, I'm merging with the state space model. I can do hundreds of million parameter model now. Then I say, okay, that's very different. Then I get even more excited when they start telling me I have this mechanistic design methodology, the div kit. That's a big deal. Okay, that's really a big deal. I use the analogy. It's like in the semiconductor industry. Before div kit, everyone has to design, route their circuit by hand. Okay, every design, silicon design is bespoke. It's the dark magic, based on experience. Today's LLM is like that. You need some people with special talent, and they cannot tell you why. They know how to tune the hyperparameter of the model and make the model work. But with div kit, it's like you have an EDA tool for silicon design. So now, I think our R&D team have a really powerful methodology and tool to manage the nightmare they are facing, managing all those hundreds of models on a phone. Because there's all those different trade-offs, and all those techniques are already built inside certificate. Plus, they also have this IP library, right? I call this IP library. They have their own foundation models. They did a great job. Just put those as just same thing. Like as your IP core inside your certificate, people can license it. Okay? That's really a big deal. No one has done that so far.
Thank you. So Raymond, why do you think OEMs like Samsung should work with us?
Well, there's no other choice, right? From what I just said, right? From business direction, this is what we want to go after. We want to work with the greatest builder out there, right? I see this team every month, there's something new. Literally, every month, there's something new. If you check their history, how the 3 co-founders founded at MIT, it's not about this, right? Every month, they invent new stuff. Impressive. So this is basically showing the strength of a really creative team, and also shows the management, how they can attract talents, okay? And how they can do business, partner with companies big, like Samsung, like Deloitte, and attract also heavy amount of venture investments, right? You need all of these. Not every entrepreneur can do this. So far, we are very excited to see Liquid AI being progressing so well, so fast on the global stage.
Amazing. So I want to say the final word, but I might be a little bit biased, but Raymond is one of the smartest investors that we have, and we really enjoy conversations together.
Yes.
And
same feeling.
Yeah. Thank you. All right. Let's wrap it up. Ladies and gentlemen.
Thank you.
Raymond.
This company came very fast. It just sort of happened. We were writing papers, and all of a sudden, we said, okay, we're going to bring this to the world.
Ramin called and said, hey, we started Liquid. How about you join us and we do something together? And then I dropped everything and joined.
I believed in their ability, I believed in my ability, and so it was a very easy decision for me to say yes.
Last fall, our tech team was basically 3 people in a shared Slack channel to now, we've grown quite a bit. But it's still, we've managed to keep that very special feeling.
I feel like what we built is so exceptional, and it's just such an, as I mentioned, it's a humbling experience to really interact with our people.
What I love the most about Liquid is really the team that we've built and the people. And I think what's also differentiating or driving us to what we do is that there's an ambition to do something outstanding, that truly to change the game.
We don't really care about all of the additional things that make things look good on the outside but really aren't good. We really care about the core attributes of what people are building.
We wake up every day and we're solving problems that the rest of the world has not solved yet. We're approaching this by not taking other technologies and trying to wrap them and package them into a solution. We're approaching it actually foundationally. My biggest inspiration was really answering unanswered questions and discovering solutions that people have spent years, decades trying to solve.
I mean, in some sense, this notion that you can actually create a brand new machine learning model that has something in common with small creatures in the natural world is kind of at the intersection of science fiction and science.
It's not every day, like Healey's comment, that something comes around, you're like, holy shit. I mean, this ain't a lemonade stand. This isn't a science experiment. This is something that can go the distance.
We see a lot of the field is driven in hype and flashy demos, but we actually hold value in something completely different. We don't want to build a company driven based on hype. We build our company based on foundational technology that works and is practically guided to deliver value.
If you scale things things are become like new new behavior get unlocked. You can build general purpose systems. We've seen the power that AI can bring us, and it opened up our imagination, like what is possible with these kind of AI systems. Being in this kind of world where AI can become smarter than the collective knowledge of the humanity, that's like the most exciting thing, and it's one of the most important things that happens in the world. And I feel like technologies like ours is going to just be absolutely necessary in this world. I need him.
Oh, you do?
Yeah.
Okay.
How long have you been doing this?
Like 5 minutes?
Okay, do more 5 minutes and I'll...
Okay.
Ladies and gentlemen, please welcome Daniela Roos, Director, MIT CSAIL and co-founder Liquid AI, Joshua Bach, Chief AI Strategist at Liquid AI, Mikhail Parakhin, CTO Shopify, and Sebastien Bubeck, VP of AI at Microsoft.
Hello, everyone. I hope you're having a rich morning. I hope you like what you hear. And hello, Seb. It's been a while.
Hi.
And in particular,
Yes.
it's been a while since we have seen the sparks of AGI. So can you tell us a little bit more about what has happened in the field since that momentous visit you made to CSAIL MIT in March of 2023?
Yeah, I remember fondly when you introduced me for that talk, which was, a very important moment for me. So I think in the last 18 months or so since that presentation, basically the word has come around, and hopefully now everybody agrees that these were really the sparks of maybe not AGI, but at least something fundamentally new. And just to give some perspective, people like Terence Tao now, the famous Fields medalist, he's saying that the latest generations of AI basically would qualify as a bad PhD student. So of course not a great one, but still, PhD student level. This is just, absolutely astounding.
So that's really extraordinary, isn't it? We have a bad PhD student that's built on terrific AI models that work based on scaling. And so I wonder, what do you all think about scaling? Is there a limit to scaling? Can we get from a bad PhD student to an excellent PhD student by scaling alone? Question for all of you. Maybe Mikhail, why don't you start?
Well, that's a very interesting question. On one hand, if you look at the log-log plot of all the models and how this quality improves with scaling, so far, all the models are on a very close to straight line, and there seems to be no end to scaling. At the same time, we have existence proof that scaling is not everything, human brain. And you could see that both in terms of power consumption and overall complexity, we will be exceeding it soon and not really capturing what brain does. So I think, and this is where I'm very happy with Liquid, because I have a little bit of a physicist background, and I've seen, finally we have differential equations coming into machine learning rather than just matrix multiplication. And so here, if you look at, say, diffusion models, there we see constraints and a lot of really ability to extract more from the same scale with Langevin dynamics and physics-inspired sort of ideas brought into the ideas of inference. So here, I'm thinking that there gotta be, again, we have existence proof that there gotta be something beyond scale, and I'm very happy that Liquid is exploring that.
Joscha, what's your take? Scaling, ceiling or not ceiling?
I think that scaling is, in a way, a cheat. It's a way to deal with a world in which you cannot play yourself, in which you cannot make experiments yourself. If you can do self-play, like you can do with chess and Go, you don't need to scale in the same way as you do with, say, LLMs and foundation models. And in the meantime, there is a deeper question, the universality hypothesis behind the scaling hypothesis, that is based on the observation that if you take different neural architectures, machine learning architectures, you give them the same data, you give them enough data, you give them enough compute, they end up with similar model capabilities, with a similar structure in the model. And there is the question, does this also translate to minds? So if we were to train a model on the input and output of biological organisms, of human beings, for long enough, with enough data, would it turn into something like a human mind? And at the moment, this is not clear. It's an open hypothesis. I think we can see that scaling makes models better. We don't really know if we run into a plateau with scaling. We also don't know how long it can continue. But as Mikhail said, the human brain is an existence proof that you can get to intelligence, not by scaling, but by being smarter about it.
So, Sebastien, what are some of the technologies we should be aware of as we think about achieving models with better and better function?
Yeah, so maybe let me relate this question to your previous one about scaling. So I think, scaling is only one part of the puzzle. And in terms of new things that came out in the last, year or so, I would say that there are essentially three trends. One of them is still, of course, the scaling up, and we want to make bigger models and more capabilities are going to be unlocked that way. But another direction, which, Liquid is also pioneering, is the opposite, to make the model smaller. And by making the model smaller, you also discover new capabilities. For example, just the cost efficiency, the speed, which allows you to do all kinds of things that would not be possible with the very, very large language model. So these are two directions, scaling up and scaling down. And then there is a new direction, which I'm personally extremely excited about, and I think unlocks a completely new direction, which is to think harder. So not only have a bigger model, but have a model that tries to do more cycle before it gives you an answer. So of course, the one demonstration right now of this new paradigm is the O1 model by OpenAI, and this is the one that Terence Tao was referring to as a bad PhD student. So I think this is a new technological breakthrough, this thinking harder, and I'm very optimistic that we haven't seen the end of scaling in that direction.
So, Sebastien, you say think harder by doing cycles. That sounds like feedback, but transformers don't have feedback. They're feed-forward mechanisms. Do you care to comment on that?
Yeah. So right now, of course, so first of all, I don't know exactly what was done in O1. And even if I knew, I don't think I could say, but I don't know. But what I can tell you is that you can try to basically mimic the feedback mechanism on the transcript of the transformer. So of course, this is, maybe not the ideal way. There could potentially be better way to incorporate this feedback, but there is at least an easy, a kind of hack to do it on the transcript of a transformer. And the amazing thing is, maybe this is not the best way to do it, but it already gives you an incredible model. So, can you imagine what will happen once somebody unlocks the right way to do it? I mean, this is going to be probably very spectacular.
Joscha, what do you think about feedback? Is it important, and how should we achieve it if it is?
I think if you have a feed-forward model that is acting on memory, then it is in some sense recurrent. And so there is some feedback. But in the way in which you mean it, I think there are more intelligent way to give feedback. For instance, when we have a conversation, after the conversation, we often rethink what happened just now. And we create a very differentiated reinforcement learning signal for ourselves that leads to us updating ourselves. And in principle, it would be possible to also have AIs that continuously learn with every interaction that they have with the world and with themselves, and in this way creatively transform themselves to get better and better. And we are just getting started in this line of research. And I think that the chain of thought that we see in O1 preview is going in this direction. And it's also something that I think most AI companies are right now exploring in their research. But we feel that we are just beginning to tap into what we observe humans being to be doing when they learn.
So I'm watching the time. We only have time for a quick question. And so let me ask a round-robin question. And this is about the impact of the various aspects of the total performance of a model, of a large language model. So what is the divide between data curation, pre-training, post-training, and model architecture? And are there other factors? What do you all think? Let's start with Mikhail.
Yeah, that's a good question. I mean, to me, honestly, it sounds a little bit like, what's more important for human life, oxygen, water, or food? And like, well, technically oxygen, but you're not going to be alive without either of them. So I think we learned recently, relearned got new appreciation for data. I know Sebastien got a lot of mileage of just thinking very carefully about the data. I think Liquid is showing that there is quite a bit to be gained in architecture itself, which for a while, honestly, like in my circles, people were like, architecture, everybody is the same, like you don't need to think about it. And then Liquid comes in. I think the only one immutable thing that I think stays for everyone is just the amount of compute. And we know this little dirty secret of the industry is that compute trumps everything, and this is for us to solve still.
Seb, how do you see things?
I don't have a much better answer than what Mikhail just said. I mean, except maybe I would add that I think we are only at the very beginning in terms of the potential, in terms of creativity for data. Because as you know, I'm very, very excited about synthetic data. And once you get into synthetic data, well, you have basically full control on what you're going to teach your AI. And your imagination is the only limit at that point. So I think we can go a lot further in that direction. But then again, everything that Mikhail said is correct. So, architecture, compute, all of those things do matter.
Joscha, you're the closer.
I think we can take a page from human beings. We have several phases when we learn. A childhood in which we need a safe environment to boot up our capabilities. And then we have a combination of online learning, and we also have offline learning, dreaming, where I basically fine-tune in synthetic data. And it seems that all these are important, but machines are not limited to this. They can exchange data between models in artificial formats and so on. So there is a way in which we see biology does it that is inspiring us, but I think we can also move beyond it in some regards.
Well, thank you all so much. This is all we have time for. There is so much we have to do in science in order to better understand AI, and there is such a great interplay between understanding ourselves and understanding AI. And we have many questions we need to answer sooner rather than later. So thank you very much.
Let me introduce again the CEO of Liquid AI, Ramin Hasani, and Ichiro Tsuge, Chairman ITOCHU-CTC.
All right. Okay, so we have Tsuge-san.
Chairman of CTC, one of the largest system integrators in Japan.
So we recently built a relationship together.
Yep.
Tell us a little bit about that.
Okay. Just today, the payment has been done. So then now we are the official partner in Japan, and we will start a strong partnership in Japan from now on.
Amazing.
May I speak in Japanese? No?
You can, yeah.
Can Liquid AI help
translate?
No, not yet.
Not yet.
Okay, not today. All right.
We'll do that in the next one.
Okay.
So Tsuge-san, how are Japanese enterprises thinking about AI?
Yeah, they are most of them thinking that they like to use AI for better productivity, of course. But at the same time, they are concerning about privacy or security things. So then, in that sense, I think Liquid AI would be the suitable tool for them.
Absolutely. And do you think, AI is an important matter to be integrated in companies? Are they traditional, or are they thinking about revolutionizing their industries with AI? How is that process?
Before talking about the enterprises, Japan has suffered from deflation economy for a long time, and now it is changing, and we are shifting to our growth economy. Most of the executives remember that we need to make investment for growth. Finally, we remembered. And then, and one more thing. In Japan, the population, working age population is decreasing. So then sometime in the 80s, it was about 87 million people, the working age population. So now maybe about 70 million. And then in 15 years or 20 years, less than 60 million. Almost, 30% less than from the peak. So then we need something to drive the growth in Japan. And I think most of the enterprises will use liquid AI because so many areas it can be applied. So, but I personally expect some good solutions in agriculture things, because again, in Japan, the food self-sufficiency rate is quite low. It's about 38%. It's the calorie base. But if you take out the rice from that, others are very low. So then to secure the food, not only for me, but it might be the good tools for them. The agriculture is one of the area where the real management is necessary in Japan, and also technology.
Absolutely. So we recently opened up a branch in Japan. This is Liquid AI Japan. And we are very excited to actually take the technology and together with CTC to deliver this technology to worldwide, like in that kind of center of the world. But what I want to mention as well is that we developed an example of the stuff that you saw in the previous hour was a Japanese foundation model that we built together. We're very excited about that. That model is a very capable language model, and we want to adopt that, as one of those examples that how we are working with enterprises like CTC to actually bring value and unlock value. So, Tsuge-san, what are the enterprises, like the sectors, that you feel like this technology can be integrated? You mentioned agriculture.
Oh yeah.
But what else?
I think so many, but maybe customer service area and the financial institute and the manufacturing. Those are our main, stream, I think.
Absolutely. All right. And what do you think is the rate of adoption right now in Japan of AI?
Oh, very few. So it is said that the market right now, this year is about $300 million a year. But it is said it will be more than 35 times in the 5 or 6 years. I don't know, but it is said. So just study it. So then next year we will see the totally different landscape there.
You saw the governor of Massachusetts spoke about the adoption of AI and how pumped up the state is about AI. How is the situation there with the government?
As I mentioned, the Japanese government remember that we need a new investment. So then they're thinking very seriously about this, and just they started to support not only AI, but advanced technology things, mainly from 2 years ago, they have started to do that.
Great. And do you think the Japanese approach right now is build versus buy? Are they building, do they want to build in-house or buy from outside?
Case by case. Some of the big enterprises are doing by themselves, but it's not sufficient by only those. We need to combine or hybrid things.
100%.
Yeah.
All right. Thank you so much,
Thank you very
Sube-san.
much.
Ladies and gentlemen, thank you. Thank you.
Ladies and gentlemen, a special announcement. We have a special guest at the end of the show, so don't leave your seats, no matter how hungry you are. Now, I would like to introduce Keith Williams, CTO of Capgemini Engineering.
We turn a little bit this way.
Yeah,
Let's look at the slide.
so that you can see the. So we have something to show here.
Yeah, we do.
So Keith,
we do.
Tell us the story. How we got to know each other?
So it started about 4 years ago when we signed a research collaboration with MIT, with Daniela's group, on trusted AI, because that was really important to us. And that's been great. That's been a big success. And then about a year ago, we found out you guys were spinning off. So we joined that party, if you like, through an investment through Capgemini Ventures, and we've now got a global partnership. So it's been a long relationship we've had.
Yeah,
and it's great to see you at this
Absolutely.
stage. Really,
Yes.
it's brilliant. It's brilliant.
So the first enterprise that we ever interacted with was Capgemini, because it was like through MIT connection. Like we were doing research together, and then we got into more commercial aspects of things. So tell us a little bit about augmented engineering.
I think we need to click the slide. Do we? Hold on.
Yes, we do. Beautiful.
Okay. So it's not what I was expecting. No, that's not what I was
This one.
That one. There you go. We'll go here. Ask me the question. It'll work.
Yeah. Okay. So augmenting engineering.
Yes. So we talk about at Capgemini, and the reason we got involved with you guys is we think about. I'm a CTO for engineering, so I'm concerned about products, how people build products, whether they be aircraft, CT scanners, cars, etc., and how you build those products and how you put AI inside of those products. And we're convinced that AI is transforming both the way you build engineered products and also the products themselves, right? But we see it very much as an augmentation of that activity. It's not some kind of magic dust that you sprinkle on engineering and all your problems go away, which is some of the narrative that you almost get. So we tend to talk about augmented engineering in terms of using AI.
Tell us about the, when you look at AI applicability, to engineering projects. Tell us examples.
I mean, I think, anyone involved in product engineering will know that it's dominated by two things, I think. Correctness, and constraints. So, if you're building an aircraft, if you're building a car or whatever it is, a good guess is not really what you're after, You actually want to know whether it's correct or not. So we've generally been looking at technologies around AI that help you solve that problem of correctness. And the other aspect is constraints, and those constraints are twofold, right? You've got product constraints, which you've touched on a lot today, things like memory footprint, real-time performance. You can't tow a server behind your car, right? And the other constraint actually is the process. people have mentioned regulation. A lot of our industries are dominated by standards and regulation, etc. So any technology that addresses the correctness question and helps us address the constraints, whether they be memory or regulation, okay, that's why the explainability is so important, is really important from an engineering viewpoint.
And how is Capgemini deploying AI for customers?
So I think we've got a slide, we'll try. There we go. Part of it anyway. So one example that we've done, I could talk you through a couple of examples, and they use the different products that you've got. Okay. One example here is for a car handbook. This is for you've got an 800-page owner's manual if you buy a car these days, and no one really reads it, and you need to be able to interact with that manual effectively. And an LLM is a really nice way to do that, but of course, from an automotive viewpoint, you're limited with the compute. Okay, you cannot assume that you've got connectivity. So we managed to deploy a really lovely owner's manual type interaction on just a conventional hardware that you would find in today's automobile. Okay, which is a really great demonstration of a practical application of LLMs when they're sized correctly. The other example that I think I'm really not.
Yeah. Now we're still.
Okay, hold on.
Oop.
Whoa.
You should have gone.
That's the one I want.
Yeah,
That's
what's
the one I want.
display?
Hold on. This one. We did another one that we've done is a project around optimization of telecoms networks. Right. And if you know this, but you use a huge amount of energy and cost in mobile networks. And we've done a great project where we've been modeling switching and antennas off, okay, in order to save energy and cost, which you can do at certain times, okay, if the operational conditions allow. And we've been using your technology, and we've been benchmarking it against other state-of-the-art deep learning technology. And basically, it's more accurate. Okay, it more accurately predicts the number of users that you're going to have. It accurately predicts the packet loss that you're going to have. Okay, and that enables you, before you do take that decision to switch an antenna off, to know that it's not going to affect the quality service of the user. Right. So we really see those a whole range of those kind of time series type problems as a real strength of your technology.
Amazing. I don't think we played the previous demo. Like, can we see it?
I don't.
I think. Let me
maybe
try.
you can work in archives beyond.
Let me see. Okay, so this one. Let's go one back. Okay, I'm just gonna play. I'm gonna play one more time and one more time. There we go. All right, so. You got the car manual over there, and a liquid model is actually offline. It's actually taking, information from that car manual. So you can imagine like uploading a massive amount of documents in there, right?
Finally, we'll show you the audio mode. In this mode, users can ask their questions using their voice. The speech is transcribed and automatically submitted. The AI responds by writing the answer and then reading it aloud. Watch the demonstration.
Okay, great.
And obviously, for a lot of clients, this ability to deploy an LLM like that in something, just a power of a normal PC is just, hugely valuable for a lot of our customers in a lot of different use cases. Yeah.
Looking into the future, where do you think AI is going? For you, for Capgemini.
Talking from an engineering viewpoint, I think what we see is what we would call hybrid AI is the real. When you look at it from an engineering domain, we think you've got to combine different kinds of AI technologies, but also with other types of engineering mathematical models, okay, that help you solve the correctness problem. And obviously, your technology helps with that, all right? And I think where you put that knowledge of physics, where you put that knowledge of the system, whether that's in the AI or it's in a different model of some description, I think will be interesting to see. But I really think it's going to be a hybrid approach of different kinds of model within the context of engineering.
Do you believe in small models or larger models?
Do I believe in small models or larger models? as an engineer, I would say that would depend on the context. Obviously, a small model is better by definition, but it depends on the quality metrics.
Yeah.
So for that, so I think it's horses for courses. I think it depends, but I definitely believe in models that are tuned to the specific problem that you're trying to solve.
Absolutely, absolutely.
That may end up being big or small. It depends what the problem is you're trying to solve.
And reliability matters.
Reliability counts hugely.
Fantastic. Thank you so much for
Brilliant.
joining us.
Thank you very
Ladies
much.
and gentlemen.
Thank you.
Keith William.
Okay.
Thank you. Thank you so much.
Hey, folks, more information on this special guest. It's a surprise that I'm going to give away right now, because at the end of the program, Stephen Pagliuca, co-owner of the championship Boston Celtics and former chairman of Bain Capital and Liquid AI, will come on stage with John Werner and have a conversation. So stay tuned. But now, I'd like to introduce Alexander Amini, CSO at Liquid AI, Stuart Schreiber, CEO of Arena Bioworks, in a conversation for you to enjoy. Thank you.
Incredible. Thank you, Stuart, for joining us today. Hi, everyone. I'd like to start by just, first of all, maybe allowing you to introduce Arena Bioworks, which is a biotech right here in Cambridge. Sure. Maybe you could share a little bit about Arena, what the vision is, what the mission of the company is, and then we'll take it from there.
Sure. First of all, it's been a great pleasure working with you, Alexander, and your colleagues. I hope we'll get a chance to talk a little bit about that. Absolutely. And congratulations. So happy to say a word about Arena Bioworks. We are a human biology-based center whose mission is to understand the mechanism of disease in the context of human physiology, and to translate those insights into new medicines through the formation of biotech companies within Arena. Now, we're able to do that because we are privately funded, and so we study disease and translate the medicines, we say, under one roof. And if anyone has seen our logo, you'll see the little roof. And so private funding turned out to be important.
Amazing.
Can I say, on the way in, I heard Steve Pagliuca mention.
Yes.
It really helps when you may all be surprised Steve has intersected yet once again. We have an amazing group of visionary investors, and Steve is one of them. He's actually our executive chair. But their alignment with the scientists of tackling big unmet medical needs and pulling in modern technology to get there as quickly as possible is kind of the magic of Arena.
Amazing. Yeah, I completely agree. And I think one of the fascinating things about the biotech field, and maybe you could speak to this a little bit, is how multidisciplinary it is. And I think the ability for AI, and Gen AI in particular, to really start to accelerate a lot of the initiatives that you have going on and the problems that the company is tackling is really transformational. Maybe you could share a little bit about the problems, because I think, as you said, it starts with those, but also your vision for how Gen AI fits into this space.
Sure, Alexander. Let me pick one or two examples. Actually, I'll pick two, and I'll pick one that happens to be what we've been working on together in our collaboration, our partnership. But I also want to share one that I think is going to be a little bit more challenging, maybe take a little bit more time, but ultimately will have tremendous impact on human health. So the first one, actually, I think it was Alexander, in your presentation, you talked about designing proteins, and we all know it's kind of amazing what generative AI has done in predicting protein structure and designing protein structure. That doesn't mean all the problems have been solved. And one of the ones that we've been tackling jointly is that these beautiful structures we see in designed proteins are largely static. Now we know that in the body, proteins move around, they're highly dynamic, and we know that it's essential for their function. You know, when an enzyme, a protein enzyme catalyzes a reaction, there's all kinds of side chain motions that are critical along that lowering the overall energy of the potential energy curve of this reaction. When a drug binds a protein, it's rare that the pre-organized structure of the drug and the pre-organized structure of the protein simply fit together by lock and key. And yet, that is where we are today. It's largely these structures that we create are static. I'm optimistic that this is a problem that we can solve. I think there's a lot of different approaches, and we've focused on one. I'll point to my personal experience in the early 1990s when I met Martin Karplus. And Martin, who's a giant in the field, came to me and actually talked about the same question of dynamic properties of proteins. And I remember in his case, he wanted to integrate what was called molecular mechanics and quantum mechanics. And his work was recognized in a Nobel Prize years later. And it really put on the map that proteins are highly dynamic, and there are ways to compute those dynamic. There is very limited in what you can do. But I think this is the time to rethink that problem from a generative AI perspective, and couldn't be more excited about doing this jointly with Liquid.
Absolutely. I think actually, so one of the things that you mentioned that got me really excited originally was that this vision that you just described is very true to the original vision of Liquid as well. The world is not static in these snapshots. The world is liquid. It's very it's adapting, it's changing, it's dynamic over time, and that's actually the roots of the architecture that we had built in the very beginning days. So I think it's a perfect problem statement. I also want to tie that into something that you and I were talking about backstage, which is the importance of basically problem-first thinking.
Yes.
Because this is also something that we hold very dearly in the company, that we see a lot of AI companies out in the world really based on hype that go after just new types of technology for the sake of building new technologies and then plug and play into existing problems that without innovating on the problem itself. Could you speak a little bit about, from your point of view, especially in a field like biotechnology, the importance of problem-first thinking?
Yes, I'm very happy to. I was listening to these talks. It was very, very interesting, but I confess that I feel very strongly about the notion in biomedicine, in the human body, it's exceedingly complex. And it really helps to start with the problem, to know what is the problem we're trying to solve. Because the alternative of creating massive data using generative AI will very likely provide useful insights, but not necessarily to solve the problem you care about. I said I was going to give a second example. I'll try to tie this in. I'm going to sort of make up a little things as I go along to try to illustrate the concept. But I think that the human body, as I said, very complex. There's a lot of things we could measure. Happily, there are things today, and we at ARENA are working very hard with partnering, including with sovereign nations, to have access to large number of participants, large number of samples from the body longitudinally. But still, what are you going to do with all of this? So I'll give you an example of the human brain because it feels appropriate with Liquid. We have major unmet medical needs in neuropsychiatric disease, neurodegenerative disease. It feels like some progress is being made. We read about new medicines. But those of us who study this really carefully, I think the lack of progress is more notable for the substantive progress. And so I think, if we tackle those problems and start with the fundamentals, like what is a brain? What is it composed of? And I think one of the things, we all intrinsically know our brain is kind of squishy. I think I heard a reference to that with the liquid model. Well, there's a reason for it. It's a sack full of what we call lipids in biochemistry.
Yes.
And these lipids are very dynamic and they're changing. And I think that if we focused in on neuropsychiatric schizophrenia or neurodegenerative Alzheimer's and got away from the biases of what we think is going on, in Alzheimer's we know that there are these amyloid deposits, but are they causal or are they a correlate? And just take a step back, gather the relevant data and the relevant generative AI, I strongly suspect that whole new concepts will emerge and they will provide a blueprint for new directions in creating the medicines we so desperately need. So I picked it as a kind of hypothetical. It's not entirely hypothetical. We are doing work in this area, and what I've outlined is sort of a summary of what we've seen thus far.
Amazing. Amazing. I mean, especially just building off of that, this loop of basically sensing and actuating, right? We want to sense the body, but then actually build back and act on it and build new things that we would want to sense from that loop is a very iterative process that I think it really also comes at the core of the mission of Liquid. So maybe I just want to end on one more question, because you mentioned earlier that Arena and Liquid will be partnering in this space of biotechnology and Gen AI at the intersection of the two. Maybe just a quick comment for the audience on why you believe this relationship is so important for you and for the field.
Yes, Alexander, it's a really great question. And it's another thing that, listening to the conversations, it keeps coming back to me. We looked at a lot of groups in this area, and to be honest, many of them sort of felt familiar, because, I think we at Arena, we have basic knowledge of what generative AI can do, machine learning can do, neural nets can, what the contributions. And we've found a lot of sort of like-minded people, and we would debate one problem over another. I think with Liquid, we found two groups that have deep domain knowledge, one in medicine, the other in generative AI. And so we had to work hard to get across the language barrier, but we were all super excited about the fact that this was potently synergistic and not, redundant in any way. So I think the deep domain knowledge and expertise of Liquid and an interest in listening to us think about some of the big unmet medical needs was kind of magical.
Absolutely. Stuart, thank you so much for joining us today. Thank you, everyone.
Please help me in welcoming back to the stage Daniela Roos, Director, MIT CSAIL and co-founder, Liquid AI, and Ralph Wittig, Head of R&D at AMD.
Hello again. So, Ralph, I'm so excited you are here with us today. MIT and AMD have been friends. We've worked on so many things together, and we're so excited to think about a partnership with you in the future. So please welcome.
Yeah, thank you, Daniela. It's a pleasure to be here, and thank you for hosting us over here today to the fantastic launch event. Quite excited to see a team like Liquid come together and really make the jump from research into the startup era, and we've got a lot of good things we can work on together. AMD Research and MIT has been, a strong partnership over many decades already, and we're very excited to collaborate now on the AI research as well. We also have a lot of MIT grads coming to AMD. There's actually a big facility right up the road here in Boxborough. AMD still does significant processor design right here in the Boston area. So all our big CPUs are designed over here, the cloud CPUs. And so we really could not be filling this talent pipeline without the strong collaboration between MIT and AMD.
So, Ralph, can you share with us the range of products AMD is focused on as one of the leaders that is building the substrate for AI?
Yeah, no, that's a really good question. Yeah, so AMD is actually a full portfolio. We go anywhere from the cloud, high-end GPUs that are really used to train AI models, CPUs, so the Instinct line is the GPU line, the EPYC line is the CPU line. They really power all the data centers around the world, and they also sit in supercomputers and national labs. We also have the gaming GPUs, and there's a lot of AI going into gaming now. And on the client side, so all the laptops that you're running, those are our APUs, right? Those are SoCs that are mixing of CPUs, GPUs, and now also NPUs. And then we also have the embedded product line coming in from the Xilinx side, where we get into close to edge, close to sensor applications, really highly efficient, and it's really ubiquitous in all kinds of applications, right? Whether that's factories or cars or healthcare, it's actually quite diverse, right? So AMD really has processors for all market segments that are powered by AI now.
So all the way from the clouds to the edge, kind of like how we think about AI, all the way from big models to small models.
Yeah, and it's interesting right now, right? So we're in, the models are being trained on these big GPUs. The big GPUs are quite power hungry, right? So they're sitting around a kilowatt per GPU. And we train scaling to hundreds, if not thousands of GPUs, right? So these big training data centers are sitting in the megawatts of power, right? And you heard about talk about scaling, right? How far can we go before we run out of or hit a plateau? The scaling continues, right? And we're going to see data centers approaching the gigawatt power usage, right? So we're getting into training clusters in the tens, if not hundreds thousands of GPUs, right? So that scaling is definitely alive and well. In the end, it's going to be energy efficiency that's going to enable further scaling over there. That's a real problem.
Yeah, I mean, in fact, energy efficiency is also one of the drivers of the work at Liquid. Traditional AI models cost so much in energy, and they have a huge environmental footprint. We are very interested in more energy efficient approaches. So can you give us some statistics on the energy cost of AI for development and deployment?
Yeah, that's also why we're really excited to be partnering with Liquid. On the cloud side, as I said, it's 1,000 watts per GPU, scaling to hundreds of thousands of GPUs, so you're getting megawatts going to gigawatts, right? On the client side, your laptop, that can't burn more than tens of watts, right? So 50 watts is already fairly power hungry, right? The actual processor inside the laptops sits at 10 watts or below, right? So now you got a single GPU at 1,000 watts in the cloud, and you got an APU sitting there at give and take 10 watt power consumption, and the actual NPU inside your laptop, the neural processing unit, is in a single digit watts unit, right? So it's quite a range we're dealing with over there. Now, the innovations we contribute is process technology, processor architecture. We're building specialized processing fabrics for training. We're building specialized processing fabrics for inference, right? But the contributions the team Liquid is making are tremendous, because we also have to simplify the models, shape them, make them efficient. This is all very important, right? So anywhere from actually training the foundational models is important. The contributions you make is really great. But then also the broad market is taking the models and is fine-tuning them for their uses, right? So the models have to fine-tune efficiently as well. And then we have to slim them for very low energy efficiency, high energy efficiency, low energy consumption on the client side, right?
That's so exciting. Listen, I just want to move through a few other topics before our slot comes to an end. Can you tell us more about client and embedded products and how they impact your revenues?
Yeah, so now, of course, I got to be careful what I say. I'm not the financial representative of the company, but if you look at public quarterly reports, you'll see that we are sort of balanced between the cloud side, the client side, and the embedded side, right? Now, the current fastest growing segment is the cloud, because we're pushing into really more training and deployment. The actual models are trained on a GPU, they're deployed on the same GPU, right? Then they get optimized for client. What we're really seeing right now is we're in the cloud wave, when a human client, a human actor interacts with a virtual agent in the cloud, right? That's the wave we're going through right now. Tremendous growth. We're all seeing it, right? You see what the GPTs of the world can do. You see what the liquid foundation models can do, right? It's quite amazing, right? The second wave is really starting. It's coming together. It's the personal AI getting onto the client side. It's laptops, it's tablets, it's your phones. So that wave is starting to take momentum. But we think that the third wave, when we get into the physical world and we get into humans interacting with physically powered AI agents and also physical AI agents interacting with other physical AI agents, that will be an equally big wave, right? So currently we're seeing that as balanced. There's a trend to cloud right now where we think the client side as well as the edge embedded side are equally important.
That's just so exciting. I can really imagine so many applications on the edge, in addition to all the many applications in the cloud. But let me ask you this. As the AI models grow in size, are there innovations that are needed in chips to cope with that?
Yeah, no, certainly. Right? So we're seeing the AI models growing in size really needs a lot of communication technology. If you look at our high-end GPUs, they're about just as much about the compute as it about the IOs, the SerDes. So we have more than 100 high-speed SerDes on a single GPU, and we really network them with other GPUs. So it's all about networking technology and that enables that scaling. Whereas this on the client side, battery-powered environments need to be extremely energy efficient. And over there, we are actually building a neural processing unit that is just focused on energy efficiency, right? And then you can take it all the way to the edge side. We're sitting there with our programmable logic fabric, and programmable logic allows you to completely customize your neural network model, you co-design with the hardware itself. We're really bringing very low precision. We're talking about binary, ternary neural networks onto edge applications with extremely high forms of sparsity, right? The human brain is somewhere between 5 to 6 orders of magnitude more energy efficient than what the cloud hardware we're building. That has to come from somewhere, right? So there's a lot more innovation we can do together, and that's on the liquid side, but it's also on the MIT side.
On both sides, on the science side and on the entrepreneurship side. So we have time for only one question, and I have to ask you about liquid. So what is the core reason you think liquid technologies and products are attractive?
Yeah, so again, I think as was stated many times today, right? We need to bring the efficiency up. We've got the scaling problems. Transformers in the fill phase are fundamentally memory bandwidth bound. Right? Driving that efficiency is really important. Bringing scale and making it scale differently is really important, and that just will enable so much more pervasiveness of AI, not just in the cloud where we have the high bandwidth, where we have the high-speed IOs to scale to many devices. We have to make it efficient for bringing it into everyday use of AI, into the personal space, and also into the physical world. Right? And that's really where Liquid's focus on energy efficiency in the models is really important for us.
The interplay between AI body and AI brain is so important to AMD, to Liquid, and to advancement in AI. Thank you so much for sharing your thoughts with us. Let's give Ralph a big round of applause.
Thank you, Daniela.
Thank you.
That was great.
Thank you.
Thank you.
And now I'd like to invite back on stage our CEO, Liquid CEO, Ramin Hasani. Ramin?
Help me in welcoming Ramin Hasani, CEO, Liquid AI, and Steve Pagliuca, co-owner of the world champion Boston Celtics and former chairman of Bain Capital and a Liquid AI investor.
Okay, this was a surprise. So thank you, Steve, for joining us. Congratulations on the Boston Celtics.
great to be here.
Thank you. I'm going to keep it very short for all of you, so let me just ask right into it. Why did you invest in Liquid AI?
Well, I need a couple days really to talk about that, but I'll keep it short. You know, I go way back and starting out at Bain & Company in 1982, and we were advising tech companies at the time, and I go so far back, it's hard to believe. My first client was McCormick & Dodge. It was a company on 128, and they had invented packaged software for accounting. And back in those days, you had a company like GE would spend $25 to $50 million to build a proprietary accounting system on a mainframe. And Frank Dodge had the idea of, why don't we package that, which will lower the cost dramatically, and we could sell those packages at the time for $2.5 or $3 million. And that was a venture startup company I was advising. So I got really interested in technology and the changes I've seen and the dramatic things that can happen, i.e. reducing the cost from $50 million to $2.5 million through packaged software. And then you fast forward, we started a technology fund at Bain Capital and actually helped start the Gartner Group, which was referenced today. Now I think we invested $6 million equity, and now the company's worth $35 billion equity, which I hope will happen with Liquid AI as well at some point in the future. But as I've looked at the whole landscape and all this tech investing, we've seen major disruption. You know, one of my, unfortunately, also early clients was a $100 million time-sharing business. So we went from mainframes, you know, to time-sharing, and then this company bought the time-sharing company for $100 million, and 6 months later, 1 year later, it was worth nothing because we went back to distributed computing. Then the internet came in. I would step back and say, why did we invest in Liquid AI? I think Liquid AI is a transformative technology, transformational technology. It is going to have the same kind of impact in AI that we saw from the internet on business and commerce and exploration and knowledge. And if you look at what are the problems with AI, the big problems are the enormous power cost. I think close to 500 million in GPUs alone to load ChatGPT-4, and that number is growing, you know, all the time. Secondly, these models are hard to explain. You know, the hallucinations, and people talked about it today. And thirdly, you know, Liquid AI offers flexibility. So really, the key factors are sustainability, a lot less power use, explainability. And then flexibility, as we talked about, you can do smaller models, large models, the whole 9 yards, and then you combine in the ability to do time series, which I think is really, really important in financial services and many of the industries. We were very excited about that, and I think it's going to revolutionize AI and actually make AI accessible to many companies. When you think about companies that want to be proprietary, you don't want to put all your information in the world and take some outside information, put it on a public cloud or put it in a public piece of software. And you can't load a model. No, companies can't spend $500 million to load their own proprietary model. But with Liquid AI, companies can have flexible models that you can load for the 5 to 10 million, 5 million, 10 million. Some of these applications that we talked about with Arena, biotechnology, protein analysis and folding, incredible things that you can do that you really can't do if it costs you $500. You think about it, if every company had to spend $500 million to load a proprietary model, we'd have a very slow adoption of AI. So what is the reason we invested? We invested because it's a fantastic team out of MIT, first of all. Congratulations. Thank you. Second, because we think it's a revolutionary technology that will make AI ubiquitous, both on a vertical and a horizontal basis in vertical applications and horizontal large language models. And it has the explainability, the flexibility, and sustainability that people will be looking for. So in a nutshell, that's why we're very excited to back the company, and we're looking forward to really seeing it take off. I also think it's great for Massachusetts, as the governor was here today. In 2009, I wrote an editorial that we shouldn't lose the biotech sector and the tech sector like we lost it off 128 30 years ago. And then Deval Patrick came in. They committed $2 billion to biotech. They've committed to AI now, and I think we can really want to protect that ecosystem in Boston. So I think it has social and Massachusetts implications as well. So we're very excited to be a big investor in Liquid AI.
All right. That's the perfect wrap for our day. Thank you so much, Steve. So,
and Ramin, why don't you put on the championship ring for the final act?
Oh my God! Wow. Amazing, amazing.
And are we gonna have the team coming out here? Is the team coming out here?
Yes, yes. So, thank you very much, everyone, for joining us today. This is a wrap. We are very excited. We are early on in our journey, but we're very excited to actually get you all access to the technology, get in touch with us. And before finishing, I just want to mention that this is all a team effort. So whatever you've seen today, it's basically the magic of people of Liquid. So I want to ask the people of Liquid, whoever works at Liquid, you've got to come on stage, and please give a round of applause for the Liquid AI team.
I have one final surprise. I have a custom Lenny Kravitz edition Dom Perignon for the Liquid team, and they're going to store this and we'll drink it when they reach 100 million in sales.
Let's do it. Thank you so much. Thank you. Don't get used to it. All right. All right. Thanks, everyone. Woo!
Yeah.